Hello, and welcome to this module on buffer overflow. Let's take a look at what we'll be covering in this video. We'll kick off with what a buffer overflow is, then we'll move on to how a buffer overflow actually works, the actual walkthrough of memory, and then we'll look at some countermeasures. Let's get started. So what is a buffer overflow? Well, a buffer overflow, according to the definition, is an anomaly where a program, while writing data to a buffer, overruns the buffer's boundary and overwrites adjacent memory locations. So what does that actually mean? Well, in programming terms, when you are allowing user input or service input from externally, you write the data to a variable, and that variable is generally saved in your computer's memory, your random access memory. You know, if you've got 4 gigs, that's pretty much what we're talking about. It's saved somewhere in that 4 gigs. But the way a buffer overflow works is if you don't write your program properly and you only allocate, let's say, 500 characters for first name as an example, but somebody goes and puts 600 characters into first name, then the 500 characters will fit in the buffer, but the extra 100 characters will actually overflow, hence the term buffer overflow, into adjacent memory locations. And those adjacent memory locations are actually executable memory locations. And then from there you can actually execute code that then runs and makes the application vulnerable. Let's go look at the example through a buffer overflow walkthrough. Okay, so here is your buffer overflow walkthrough. And let's take a look at how the buffer fills. So the buffer fills from the bottom up. And this is literally an example of how the buffer works. It's different for different architectures, but the concept is exactly the same. So as you start filling your characters in your buffer, let's just say first name of 500, it will start filling all the way down, but your stack starts filling from here up. And your stack is your pointer. In other words, it's actually the metadata of where the data is. So as you start filling it up, let's just say you've got 500, it will start here, it will tell you where the stack pointer is starting. Then your buffer will go to 500, and then as soon as you hit 100, you're going to start hitting this thing called alignment space, which is actually just something the CPU puts into memory just to make sure that it runs quicker depending on which architecture you are. Then it will hit the extended base stack pointer. And what you want to do in a buffer overflow is actually overflow to a point where your characters hit this extended instruction point, because this is the next instruction for the application. So if you put your characters here and say open a file, then your extended instruction point will then write back to the buffer and then basically execute the application. So let's go through that again. Okay, so we're going to go through this one more time. So basically what we'll do is we start with the extended stack pointer. So let's start with the first name of 500 characters. That is what the program is expecting, but we're going to give it 600 characters. So the first 500 characters are going to go all the way up, and they're going to hit this line here. Then the next 100 characters from 501 to 600 are actually going to fall all these things here, which is actually what it's not supposed to do. It's a vulnerability, it's an anomaly. It's not supposed to do that. And the next 100 characters will fill here. But if we can get the 100th character to actually sit inside this EIP, inside the extended instruction point, which points to somewhere where the memory, where the application, is supposed to execute, you can, at your 600th character, get the application to actually execute code, which it's not supposed to do. You're not supposed to have data execution in memory. Data execution is supposed to happen via the CPU. So that is in essence what a buffer overflow is. There's a lot of tutorials out on the internet, and it does take a little bit of time to get this into your head because it is quite a foreign concept. But in essence, I hope that I've explained it as clearly as I possibly can. Let's move on and look at some countermeasures. Okay, so what do you want to do? Well, the first thing you want to do is you want to write programs that actually do not have buffer overflow exploits in them. And you do this by a form of code audits, and that's literally just making sure, if you're a software developer, to get your code reviewed before you actually submit it. And it's just generally good software development practice to do that, in essence, not only for buffer overflows, but for a whole bunch of other vulnerabilities and efficiencies. The next thing you want to do is you want to use framework libraries and good compilers. So buffer overflows have been around for a very, very long time, and the good frameworks like .NET, Java, etc., and the compilers, things like Visual Studio, the C++ compiler, the C# compiler, the Java compilers out there, have built protection into them for buffer overflows to ensure that the code you're writing does not actually have a buffer overflow vulnerability. So it's always a good idea to use a mainstream, with a good compiler with a good framework library. The next thing what you do is disable stack execution. So what you're going to do here is, and in Windows terms, this is called DEP, or Data Execution Prevention. And basically what you want to do is you want to make sure that your operating system doesn't allow execution of data in the stack. In other words, the stack is only there to hold memory. It's not there to execute instructions. The next thing you want to do at an operating system level is randomize your memory addresses. So if you recall our buffer diagram, if you have the buffer filling up consequentially in 1, 2, 3, 4, 5, etc., it's a lot easier to craft a buffer overflow. But if you're randomizing your memory and your OS is writing your characters to totally different random places all over the memory, it makes a buffer overflow a lot more difficult, if not impossible, to do. Then finally, you want to restrict bad coding functions, and that goes hand in hand with the code audits. So there's a very famous bad function called string copy in C, and that's actually what we'll be doing in the demo. I'll show you how string copy actually creates buffer overflows. And that pretty much ends this quick tutorial video on buffer overflows. Thank you very much for watching.